In this video, we'll solve just one question under vectors. So this is the question. In the figure below, that's the figure. So in the figure below, vectors B and C are intersecting face diagonals of a cube of edge A in the planes XY and YZ respectively, with respect to a frame of reference erected at the point of intersection of the vectors and edges of the cube as the axis. Find A. So find the value of B dot C, so that is a dot product or simply a scalar product. Then B, the angle between B and C. Then C, we should find the components of the vector D, such that vector D is the cross product of B and C. Then lastly, we should find the direction cosines of the board diagonal represented by the vector E. Okay, so let's just look at this diagram, which is more clear. So we have the x-axis there, the y-axis, and the z-axis. Then this is a cube, meaning that all the edges are the same. So A, everything A. Okay. Then we have been given three vectors here: vector C, vector E, and vector B. So if we check vector C, it's in the plane YZ. It's in this side, okay, in the plane YZ, from that point to this point here. Then if you check vector B, more like it's behind there, in the plane XY, more like it's behind. Then if you check this vector E, it's coming from that corner too. So this is a bottom back corner to this top front corner. So we can say it's actually in between there. That's what we can say if we are to draw, let's say, dotted line like that. Okay, even that. Yes. So there is this plane here, which is dividing this cube into two parts, this side and this side. So it is along this plane where vector E is. Okay. So here we should find B dot C. Okay. And actually, if you need more of my lessons, you can just contact me on WhatsApp. So just text I have more lessons in the official group for PH110, MA 110, CH 110, and BI 110. So here I'm just using the concepts I already explained to apply them and answer the question. So let's proceed. Okay, so we know that these vectors here can be expressed in terms of I, J, and K. So we know that in the X there, what do we have? We have I, okay, unit vector. Then in the Y, it's J, and in the Z, it's K. Like that. Then the aim here is to find B dot C. We should find B dot C. Let me just write on this other page. So A should find the vector B dot C. So we know that by definition this is actually magnitude of B, magnitude of C, then cosine of the angle between B and C. Now in this case, if we check B and C there, do we know the angle in between? Of course we don't, but what can we do? It's better we express each of these vectors B and C in terms of I, J, and K. Thereafter, we simply multiply the corresponding components and add them, then the answer will be a scalar product. Okay. So let's continue. Let's start with vector B there. Let's express it in terms of I, J, and K. So for B, it will be equal to, so if we check, this is vector B there. It's behind that side. So meaning that it is in the X, Y plane there. Okay. So its components will be in the I and what? J. And if you check, all the edges there are represented by A, meaning that here we should have Bx, which is equal to what? A itself, this edge is represented by A. Okay, even that edge is represented by A. We should also have By there. Okay, meaning this vector B is what? Bxi multiplied by Byj, like that. Okay, we can even say multiply by Bzk. So you will say vector B will be equal to, so for Bx, we are simply getting this, the length of the edge from there to there. When we resolve B into its components, we are doing the same thing of resolving vectors into components. So this is A. Even this is A, the length from there up to there, it is A. Okay, so Bx will be A, even By will be A. So here we have Ai plus Aj plus, what about the one for K? So if you check, vector B is only in the XY plane, okay, excluding Z, meaning K will be 0. So this will be 0K. Let's do the same for C. So C will be equal to, again, if we say Cxi plus, let's say Cyj plus 0, rather not 0, Czk. Okay, then let's find Cx, Cy, and Cz. Okay, so if we come to C there, C is in which plane? It is in the YZ plane, this side. Okay, and at this point, it has this component and that component. So this component will be Cz, and this component going up will be Cy. Okay, these are the components that C has. Now, remember all these edges are of length A. So this is A, even that is A. Okay, meaning that where we have Cy, we should have what? It's Ai. So for Cy, it's Aj rather. Okay, then plus. For Cz, this is Cz, like that, and this is also A. So say A, then K. Then what about I? So this is just in the Y, Z plane, excluding the X there, meaning this is just 0. So we have 0, I, plus, like that. Then let's now find the dot product B dot C. This will be equal to, so we just multiply the corresponding components and add them. So say A times 0, A times 0 will be what? 0 plus, okay? Then A times A, that's A squared. Then 0 times A to be 0. So when we add these, we're getting what? A squared. So A squared, this is the dot product, also called the scalar product. So for this one, we are done. Then B, we should find the angle between B and C. So to find the angle between B and C, we'll get back to this. So we'll use the dot product should be equal to magnitude of B, magnitude of C, cos the angle theta. This is the angle in between B and C. Now here we should have magnitude of B and also magnitude of C. How can we find these magnitudes? So just get back to B there, which has been expressed in terms of x, y, and z already. Okay, so let's do this. If this is B, magnitude of B should be equal to, so magnitude of a vector or resultant, it's simply x squared plus y squared plus z squared, or bx squared plus by squared plus bz squared. This will be equal to, so what is our x value there? That's a. So we have a squared plus what? That's 0 squared. And this will be equal to, so here we'll just remain with a squared plus a squared, which is 2a squared. Then we can write this as 2 multiplied by root of a squared. Root of a squared, that's a root 2. So this is the magnitude of B. Then we should do the same and find the magnitude of C there. Okay, so if you do the same, you actually get magnitude of C to be the same as the magnitude of B. Remember, even C only has A there. Even B only has A, the other one is 0. So we expect its magnitude to be A root 2 as well. Okay, you can confirm. That's what you get. So these are their magnitudes. So we get back to our formula there. B dot C, we just got a squared equal to, so here magnitude of B, a root 2, multiplied by magnitude of C, a root 2 cos theta. Let's proceed. So here we'll say a squared will be equal to, so at this point we can just multiply a times a will give us a squared, then root 2 multiplied by root 2. Okay, same as root 2 raised to the power 2 cos theta. So here we can say a squared being equal to, so the root there will simplify with the square, will remain with 2a squared cos theta. Then what should we do? Let's divide both sides by 2a squared over 2a squared, meaning that 2a squared will simplify. We have remained with cos theta being equal to, so a squared 1 over 2, and theta should be equal to cos inverse of 1 over 2, or simply 0.5. Therefore theta will be, so cos inverse of 0.5, that is 60 degrees. So 60 degrees is the angle in between B and C. What else are we supposed to find? For C, we should find the components of the vector D such that vector D is the cross product of B and C. So how do we find the cross product? So we are still using the same vectors B and C. So let me just write them here. Vector B is actually AI plus AJ plus 0K, and vector C is equal to 0I plus AJ plus AK. Okay, then we should find another vector D such that it is the cross product of B and C. Yes, the cross product of B and C. So how do we find the cross product? It is simply the determinant of a 3 by 3 matrix. So from what we have here, we should form a 3 by 3 matrix. Then why am I using these straight lines? So for determinant, use straight lines, showing that you are now finding determinant. Okay, so on top there we know we should have I negative j k. Then here we have b dot multiplied by c, or b cross c. So get the coefficients of the vector appearing first. That should be your second row. Okay. So if we had, let's say, c cross b, you first get the components of c being in the second row, since this is the first row, second row. Okay, let's start with b. So this is b. Get the components. That is a 0. So you should have a and 0. Then let's go to c, the last one. Okay, so for c, this is 0 a 0 a, like that. Then from there, we should then break down this 3 by 3 matrix into 2 by 2 matrices. So let's do this. You pick I, so let's pick I. If we pick I there, so you write I, okay. What you have to do is that everything under I there, or should I say, let me use red, okay. Or should I say the column and the row of what you have picked should be eliminated. So you eliminate these. And whatever remains should give you a 2 by 2 matrix. This is what remains. That should give me a 0 a 2 by 2 matrix. Pick negative j. Moreover there it should be negative j always. It's I negative jk. Okay. Then you will, let's say, negative j. So if we pick negative j there, we pick negative j, it means that the entire column of negative j should be eliminated. So this entire column should be eliminated, and the entire row, this one, should be eliminated. Then whatever remains, so our main concern here is negative j, not I. Yeah. So what will remain? Will remain with this and that. So whatever remains should give you a 2 by 2 matrix. So a 0 0 a, like that. Then plus k. Again, when you pick k there, the entire column of k should be eliminated, and the entire row of k should be eliminated like this. Then what remains should give you a 2 by 2 matrix. So we'll remain with a 0 a. Then here just find the determinants of these 2 by 2 matrices and sum them up. Okay. So here we know that determinant of 2 by 2 matrices is we just multiply the major diagonal, then minus product of them, minor diagonal. So this is what we do. A times A will give us A squared. So we have A squared. Then A times 0, that's 0. So minus 0. Then you bring your I like that. Minus this sign there. A times A, that's what? A squared. That will be minus 0. You bring your j there, the sign there plus. A times A will be A squared. This will be still be 0. Then you bring your k there. So this will be A squared I. Then this will give us negative A squared j plus A squared k. So this is the new vector D. Now according to the question, they want the components of the vector. we get back to the question then. Find the components of the vector D. Okay. Upon finding the cross product, meaning dx will be equal to what? It is this one. Dy will be equal to negative a squared, and the component in the z will be equal to a squared. That's it. Then let's see what other question do we have. Find the direction cosines of the board diagonal represented by vector E. Direction cosines of the board diagonal represented by vector E. There. Okay. So this vector E makes angles with the coordinate axis. So this is what we are talking about here. In between, well, let me just use this. In between this y and the vector E, there is this angle. Okay. Again, in between the x-axis and the vector E, there is this angle. At the same time, in between the z-axis and the vector, there is that angle. These angles are represented by alpha, so this is alpha, beta, and gamma, like that. Okay. Then here we have to find the direction cosines. So these direction cosines are simply the cosines of the angles that a vector there makes with the coordinate axis. And we know that these are given by, so cos alpha is actually equal to x over r, where r is the resultant, or let's say the magnitude. Then cos beta is equal to y over r, and cos gamma is actually equal to z over r. Okay. So here we should just determine what is x, r, and that r is just the same for everything. Where r, this r, where r is equal to, so we say, where r is equal to x squared plus y squared plus z squared. So let's identify which one is our x, y, which one is our z. So if we get back to this, so here our main interest is now this vector E, which is along this plane, which is cutting actually the cube to two parts. So this vector E is in the x, y, z plane. Okay. So at this point here, what we can just do is that let's get these as the components. For simplicity, we know that all the sides are the same. It will mean that x from this point to the x-axis there, it is what? It is a, right? Yeah. From this point to the z-axis, so this is a, this is a there, even this is a. Okay. So from this point to the x-axis, it is a. This point to the x-axis, a, to the z, a, to the y, a. So here we can say vector E in terms of x, y, and z. The vector E in terms of x, y, and z will be what? AI plus AJ plus AK. Yeah. All the sides of the cube are the same. So here we'll say the resultant will be equal to, this will be a squared plus a squared plus a squared. So R will be equal to a squared plus a squared plus a squared, that is actually 3a squared, and we can write this as 3 root of a squared, which will give us what? This is a root 3. So this is the resultant. So whenever we have R there, we'll write a root 3. And remember, for each of these, x, y, z, we just have a as the components. Therefore, cos of alpha will be equal to x over r, then for x we have a, over what is r? A root 3. And this will be 1 over root 3 when you simplify there. Same applies. Cos beta will be equal to y over r, and for y we have a over a root 3, giving us 1 over root 3. Then if we say cos gamma, this will be equal to z over r, a over a root 3, giving us 1 over root 3. So these are the direction cosines of that vector E. Okay, so that's it for this video. I hope you have understood.